be here, and let's take a look at the types of nuclear decay. Let's begin with alpha decay. This has the symbol shown here, and this consists of 2 protons, 2 neutrons. Since this is the mass number here, protons plus neutrons, we already have the 2 neutrons. That does correspond to helium. Helium must have 2 protons. And we have a charge of +2. That must mean there's no electrons at all. We call this an alpha particle. It also could be described as a helium nucleus or a helium dication. We can show an example of this for this balanced nuclear reaction. You can see that uranium-238 is undergoing alpha decay since it's releasing an alpha particle. And what must it form? Well, it lost 2 protons, so it must be the element that corresponds to 90 protons. That's thorium. So we would say uranium-238 forms thorium-234 when it undergoes alpha decay. Surprisingly, this doesn't require much shielding to protect you. Another type of decay is known as beta decay, sometimes with the negative sign. There's the symbol for a beta particle. And things are going to start to get a little unusual. The bookkeeping is easy, the describing not so much. Here's what a beta particle looks like. It's an electron, and it has a -1 charge. That's what electrons do. But why do we have the number of protons designated as -1 and the number of protons plus neutrons as 0? Well, this makes sense if the electron was ejected from the neutron, forming a proton, so that you end up forming a proton, but you also lose a neutron, so that there's no net change in the mass number. It's so much easier just to show it like this, because if you're undergoing beta emission, it must look like that. That's what it is. And then you just do the math. If it was thorium-234 undergoing beta emission, 92 minus 1 equals 91. 234 plus 0 equals 234. So when thorium-234 undergoes a beta emission, it'll form uranium-234 plus the beta particle. You need a little more shielding to be protected from that. Another type of emission is beta emission with a positive charge, otherwise known as positron emission. Positron, as you might guess, consists of an electron with a positive charge, which electrons don't have. But mathematically, this will all make sense. It looks like we have 1 proton, but no protons plus neutrons. It all seems kind of strange, but here's the magic words that might help make sense of it. It's a positively charged electron. Check. It was ejected from a proton because there it is, that proton to begin with, but it forms a neutron. So once again, you get rid of a proton, you make a neutron. There's no net change in the mass number, and here it is mathematically. I recommend, if you're looking at this for the first time, to just focus on how the balanced nuclear reaction is pretty easy to follow. 10 plus 1 equals 11, 21 plus nothing equals 21. When sodium-21 undergoes positron emission, it would form neon-21. Is this reasonable? Well, that's one of the questions. Don't forget that the neutron to proton ratio, if it exceeds 1.5 to 1, it's an unstable nucleus. If it's between 1.5 to 1, which by the way this is, it looks like it's an 11 to 11 ratio. No, 10 to 11 neutrons is 10. Yeah, 10 to 11. It's an interesting number. And this requires aluminum shielding. Finally, we have gamma emission, which is just pure energy. Notice 0, 0, just pure energy. So I won't bother showing a reaction for that. Nothing would be changing. And let's try to use the lingo to describe what's happening in each one of these processes. This looks like a neutron to me, right? No protons, 1 proton plus neutron. Hey, that's a neutron. It's turning into a proton. That's reasonable for a proton, right? And an electron, but no, that's not a garden variety electron. That is a beta particle. So a neutron is converted into a proton plus a beta particle. Try the same for this one. Pause it if you need to. Okay, what I see is a garden variety proton, just like we saw there. and it's turning into a neutron. That is what a normal neutron would look like. It has no protons, and P plus N equals 1, plus an electron, but wait a minute, that is not a normal electron. I guess you could say it's a normal electron once it happens, but it is coming from it is defined as a positron. So it looks like a proton is forming a neutron and a positron. There is another type of decay when it doesn't form any of those types of particles, and that's spontaneous fission. And this is an introduction to the types of nuclear decay.